Hey guys, Buildzoid from Actually Hardcore Overclocking here, and today we're going to be taking a look at the Gigabyte X470 Aorus Gaming 7 Wi-Fi for the Ryzen 2000 series CPUs. As well, technically it can also run the APUs and it can also run the 1000 series, but you should really only be considering this board for like the 2000 series. I guess if you're on a bad 1000 series board, upgrading to this would not actually be a bad idea. Anyway, before we get into the VRM details here, I'm just going to point out some overclocking features that this board has. Not that it has many.
Before that, this video is brought to you by Thermaltake's View 37 case. The View 37 focuses on highlighting custom PC builds with its full panoramic window and tinted front acrylic. In our thermal testing, the View 37 performed reasonably well when considering its looks-focused build, which is partly thanks to the airflow design and the removal of a bottom power supply shroud. For a balance of looks and performance, check the link in the description below for the View 37.
There's this auto OC button, which you should never use because it's probably gonna load up some awful, really like miserable settings that are either too much voltage or not stable. Because I've never seen one of these actually work well. But the other OC feature, like the actually useful OC features you do get, is a postcode down here. And then these two switches. There's unfortunately no power button, no reset, no retry, and no safe boot on this motherboard, which makes me really, really sad. But for most users, those are admittedly kind of unnecessary, whereas these two are actually really, really handy. So these two switches here, one is BIOS mode. So basically, this being a Gigabyte motherboard, obviously has a dual BIOS implementation. You have a main BIOS and a backup BIOS. And basically the BIOS mode switch allows you to go between single BIOS and dual BIOS modes. And the reason why you'd want to go between single BIOS and dual BIOS is because this sometimes on some Gigabyte motherboards, dual BIOS modes tends to go derp. It tends to be a little bit buggy. It tends to have issues. It sometimes won't update the secondary BIOS. You know, you update your primary and it just refuses to update the backup. So if you ever screw up your main BIOS, you're going to have to do a BIOS update because it'll go to the backup and the backup's going to be on like a BIOS version that's way too damn old. Other issues include, say you screw up your memory settings and you fail to boot a few times in a row, the backup BIOS will randomly decide that it'll overwrite your primary, and you know, that's just like, it gets kind of old if you're running, you know, if you're trying to do some overclocking that isn't that is really tripping up the dual BIOS implementation, because it sometimes just does silly things. So you can put the board into single BIOS mode, and what single BIOS mode basically does is you can be either on this chip or on this chip. The board will not try to automatically recover for you. And so what do you do if you screw up while you're in single BIOS mode? Well, you have this switch right here, which allows you to choose which BIOS. So like, that is a straight up BIOS switch. So yeah, this is a handy feature to have. Like normally I'd be most boards where it's like I think for the bare minimum implementation of dual BIOS, you really should just have a switch and two BIOS chips. Gigabyte tends to do the opposite. They have two BIOS chips and a bunch of fancy software and no switches, which, you know, as I said, tends to sometimes get kind of infuriating, because the dual BIOS mode on some motherboards tends to be a little bit less than intelligent. So yeah, that's a nice feature to have. And then there's the postcode. There's no reset, like there's no retry, safe boot, power reset, or anything. Clear CMOS is done by a jumper down here. That's not the worst way to do it, honestly. Like, I mean, I'd prefer a button, but hey, at least it's just a jumper and it's down here, easily and accessible enough. You do get some quick debug LEDs right here, but I don't see why you'd use them when you do have the postcode. So yeah, that pretty much covers the quality of life features for overclockers on this motherboard. I'd really like that power button, as well as the reset at the very least. But at least there's the, you know, manual BIOS controls, which I do appreciate that, because I have run into issues with Gigabyte's dual BIOS implementations a few times. Nothing as serious as like outright breaking a board, but not being able to run the board because wasting time waiting for the BIOS to flash over because the primary is a little bit screwed up and the backup decides to just randomly update it is just not, the most pleasant experience. So I do appreciate that they put the BIOS switches on this one. Now then, let's get to the VRMs, starting with the ones around the CPU socket, which are the most important ones. This L shape right here, which I'm not nailing, this L shape right here is your vCore VRM. And then next to it, you find the SoC right here. So that powers the iGPU and the SoC portion. So iGPU on the APUs, and for the Ryzen non-APU CPUs, this powers the memory controller and the USB, like some of the USB ports, the PCIe and all of that. This powers the cores. So yeah, both of these are controlled by the International Rectifier IR35201 here. And this time around, the 35201 is configured in a 5+2 phase configuration. This does technically look like a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 phase, and it is marketed as a 10 phase, and that's actually completely fine. Because Gigabyte does actually have a doubling scheme. You have one doubler up here, and then if you go onto the back of the board, you get a bunch of them along the back here. So you have 5 doublers total, and these are the dumb kind of doubler. These are International Rectifier 3599s, and these literally just pass the PWM signal between 2 phases, but at least you don't have, at least you won't ever have 2 phases turning on at the same time, like some of the not really doubling schemes that a lot of other motherboard manufacturers like to use, especially on low-end motherboards. So this is a 10 phase by the most basic definition of what a 10 phase would be. This is a 10 phase. It's not as good as if you had a real smarter doubler or just a straight up 10+2 phase voltage controller, but it is a 10 phase. Gigabyte can call this a 10 phase. That's fine. And then the SoC VRM is just a straight up +2. There's no doublers for that. The power components themselves are, the MOSFETs in this case are International Rectifier power stages. For the vCore VRM, you're looking at International Rectifier IR3553s, Gigabyte's favorite 40 amp power stage. Like, there is so many motherboards they put these on that it's just like, literally they must have some kind of crazy discount on these, because Gigabyte uses these everywhere once you get past a certain sort of price point for their motherboards. Like, there's motherboards where they use these for memory power, which is just completely ridiculous because it's a 40 amp power stage, but nonetheless, perfectly good part. It reaches peak efficiency at 12.5 amps output, and that's kind of a problem with this 10 phase right here, because if you're on like a 6-core or a quad-core, or you're just not overclocking, this VRM will have to shut down partially. Like, most of this VRM should not be running if you're running at stock settings, because it's just going to be horrifically inefficient if you're running if you're pushing 5 amps through one of these power stages, you're going to have the bulk of the power loss across one of these power stages at that point is going to be the act of turning the power stage on and off. Like, the drive circuitry itself will be the bulk of your power loss. And so basically, for light load efficiency, this thing should drop phases, turn off, basically. Like, if you're on a quad core, it should just turn off all of those. Or like this. I'm really not sure which order they're wired up in, but basically this thing should drop down all the way to a 4-phase for idle, or a quad core maxed out, because they're not that power hungry. For a 6-core, this should be running around 6 to 8 phase mode. And then if you're on an 8-core 2000 series and overclocking, it should actually go into the full 10 phase mode. But otherwise, this thing should be just disabling phases, because it's just wasting power otherwise on just driving them. So it's kind of an interesting issue with having a big multi-phase VRM, but obviously the IR3520 does support that functionality. I'm also pretty sure the Gigabyte BIOS actually allows you to enable and disable like the number of phases that the board will run. So there should be, especially for like this class of board, there should be a manual override to force the board into 10-phase mode if you don't care about VRM efficiency and just want the best voltage regulation, which you obviously get with more phases rather than top efficiency. Anyway, let's talk actual power capabilities. So Gigabyte has a ridiculous a real heatsink for their VRM. It's not really that ridiculous, but this is a real heatsink. That's nice to see. But they do have the real heatsink for this VRM. But honestly, it might not even be that necessary because Ryzen 2000 series 8-core is a little bit more power hungry than its predecessor, the 1000 series. But you're still looking at, for the 8-core, right? If you go 8-core, 1.42 volts and 4.2 gigahertz or, 4.3, you're going to be looking at about 125 amps of current coming out of the VRM. Which falls right within that peak efficiency figure, doesn't it? It makes perfect sense why Gigabyte went with this 10-phase right here, because they're gonna nail that if you're on a 8-core Ryzen doing around 4.2 to 4.4 with maxed out V-core. For that, you're gonna be looking at about 15 watts of heat dissipation for the entire set of MOSFETs right here. So it's nice efficiency right there. That's actually really, really solid. Nothing to complain about there. Now, if you're on an 8-core first gen and you're at 1.42 volts, you'll be looking at about 100 amps, which, I'm assuming around 4 gigahertz. You're going to be looking at around 100 amps, and that will produce about 12 watts of heat. This is also technically kind of relevant for a 6-core 2000 series, like those figures right there. 6-core 2000 series, a slightly higher clock, about 90 amps instead of 100. So you'd still be looking at about, 10 to 12 watts of heat. Now, if you're on a 6-core first gen, the VRM will have to start shutting down phases again for efficiency, because at 1.42 volts, those and, 4 gigahertz, you're going to be looking at about 75 amps of current output for the VRM, which is just way below the efficiency floor for these power stages, and you're going to be looking at about 10 watts of heat in 10-phase mode. It'll actually get more efficient if it shuts down phases. And if you're on a quad-core, which would be like an APU or something, 1.42 volts, 4 gigahertz, you're going to be looking at about 50 amps of current draw, because there's currently not a 2000 series quad-core. And at that point, the VRM, if you're running 10-phase mode, it'll produce 9 watts of heat, which just looks awful. If the VRM drops into 4-phase mode, which should be pretty much close to peak efficiency for, it'll be peak efficiency for 50 amps output. If it drops into 4-phase mode, it'll drop down to about 6.2 watts of heat output. So basically, if you want to, you should really run this motherboard with an 8-core. Because otherwise, most of this VRM will just turn off and you're not using it. So waste of motherboard components if you're on something less than an 8-core on this. Because seriously, it's not efficient. Running a 10-phase for these lower core counts is not efficient. So yeah, that's the V-core VRM situation. Now the SoC VRM is made up of one last figure I forgot to mention. If you had an 8-core on liquid nitrogen and we're pushing about 1.85 volts, 5.3 gigahertz or 5.2, I don't have data for what the 2000 series will actually hit in terms of frequencies on liquid nitrogen yet. 5.3 gigahertz, you'd be looking at about 200 amps of current and about 31.2 watts of heat. So there, the heatsink might actually come in useful, though with how Ryzen runs and how long benchmarks on liquid nitrogen usually last, that heatsink might turn out to be unnecessary, and this area of the board will probably, this entire area of the board probably ends up covered in ice if you run it on liquid nitrogen. So the VRM will be sub-ambient, unless you're constantly running running a really, really long benchmark over and over and over again. the board will be covered in ice. So yeah, now the SoC VRM, different current figures, obviously, very different. This is a two-phase design right here, and you do get the power stages. There are International Rectifier 3556s, which is Gigabyte's second most favorite power stage. It's a 50 amp part, and massively overkill if you're on a CPU Ryzen, and if you're on an APU, it should still be plenty powerful. Though I don't think putting an APU in this board is exactly cost effective. So, for a regular Ryzen, you'd be looking at about 1.2 volts to, 1.2 volts SoC voltage and 20 to 30 amps of current, which will produce about 2 to 2.5 watts of heat. So, nothing. Like, this would get away with just past, like, no heatsink whatsoever. And if you're on an APU, you might go to, like, 1.25 volts, because you do need to, for the GPU runs off of that too, and also the SoC might actually have an upgrade to be more voltage tolerant. But 1.25 volts on that, and you'd be looking at about, say, 40 to 60 amps of current, depending on what kind of iGPU overclock you have, and if you're running the 2400G or the 2200G. And for that, you'd be looking at 4 watts to about 7 watts of heat output for the SoC VRM, so not much. So yeah, this is plenty powerful enough as well. This VRM is really, really solid. It's not the most powerful one on X470, but I think going over, getting anything stronger than this is probably completely unnecessary for the Ryzen 2000 series if you're on ambient cooling. If you're on liquid nitrogen, there might be some justification for a stronger VRM than this, but because, you'll be pushing like 200 amps of current through the V-Core VRM, and then some higher end power stages or just more phases would actually further improve efficiency. But for daily usage, this is plenty. Like, this is actually overkill for most CPUs and most people's overclocks, because you'd really have to hit that 1.42 volts figure to even get this VRM into the peak of the efficiency curve for these power stages. So yeah, great job Gigabyte on the V-Core VRM as well as the SoC. Interesting note about these inductors that Gigabyte uses. So I actually managed to get this is a useful part number, so I managed to get the data sheet for these. These are from Eaton, so EA10, yeah, and that is these guys supply a lot of high-end inductors. You find them on AMD reference cards, server boards, these are high-end. And so these are rated for at 125 degrees centigrade, because these are inductors. They can tolerate stupid high temperatures, similar to MOSFETs. Really, the most temperature sensitive component in a VRM is your aluminum polymer output capacitors, and then the little ceramics in the VRM itself, though you can get those in 125C rated versions as well. You can technically get 125 rated aluminum polymers as well, but those are really expensive compared to 105C rated counterparts. Anyway, the inductors, 125C, you're looking at a average current capability of about 61 amps. So that's how much current you can push through these before they start getting steadily hotter and hotter and hotter and hotter. So this is way beyond what this motherboard needs to be able to handle. And for saturation current, which is basically where the saturation current is 70 amps, and that is the current level at which the inductor basically stops being able to, the magnetic field of the inductor stops building, and it basically starts turning into a short circuit. So basically, if you exceed that current level, the inductor, in a buck converter application, that is really, really bad. You really don't want to hit saturation point. But as we kind of covered, Ryzen 2000, even on liquid nitrogen, should not be going it shouldn't be getting anywhere near these kinds of current figures, because you'd have to be at to get anywhere near the saturation, or even the average current capability of these inductors, you'd have to be pushing like 600 amps through this VRM. There is no way a Ryzen is pulling that, not on an 8-core anyway. So yeah, these are ridiculous overkill from Gigabyte. But, you know, that's nice to see. And they do use them on a lot of high-end boards, and I guess they just have a ton of them, so why not use them on this board as well? The capacitors, at least these, I'm not sure about these. These look a hell of a lot like APAC, this manufacturer, and they're Taiwanese. But all of these black, you know, aluminum polymers, those are FP series Nichicons. I don't know the hours rating, because normally the FP series has like this model name right here normally has the hour rating in it, but Gigabyte opted to not have that, so these might be 5,000 hours, they might be 10,000 hours. I really hope that they're not just 2,500 hour capacitors in black paint, though that is technically possible. But yeah, these are, Nichicon is a Japanese capacitor manufacturer, and these are, you know, as good as it gets basically for motherboards. You won't find anything really better except other Nichicons for higher hour ratings. So yeah, but these should still be 5,000 or 10,000 hours rated. But I can't, you know, find the specifics. Anyway, that covers the CPU power situation. You get some minor buck converters down here, which I don't know the power levels for. The MOSFETs here are on semiconductor 4C10s for there. The voltage controllers are Richtech RT8120Ds. So these two control chips, and I'm not sure what voltages these generate. They should be something like VDDP as well as some of the PLL voltages. So yeah, but this is these don't push that much power, so I'm not worried about those. For your memory power, you're looking at this single phase right here, controlled by yet another RT8120D, and the MOSFETs used here are 4C10Ns in the larger package, so that's actually the same MOSFET. So that's on semiconductor again. That's the same MOSFET as this, just different packaging size. And you have one high side FET and two low sides. So the one with the X is a low side. And the end result is that this memory VRM can push 6 amps, 1.35 volts to your 4. That's for 4 memory sticks, because DRAM, DDR4 doesn't pull that much power at all per stick. And actually, this is probably higher than what you would see at 1.35 volts, or even 1.5, or maybe even 2 volts. Like, memory really doesn't use a lot of power, and its power usage doesn't even really scale with voltage. So you can crank a lot of voltage into memory, and its power consumption doesn't really change. Anyway, for 6 amps, 1.35 volts, you'd be looking at about 0.8 watts of heat. For the MOSFETs right here, the controller would obviously add to that overall power draw figure. So yeah, that pretty much covers everything on this motherboard. There is a clock gen on this board. I'm just not sure where it is. It might be this, but when looking, I can't get a particularly helpful data sheet for this chip right here. And any mention I've found of this is just that it's a clock buffer. So yeah, there's not really any details on what exactly it's capable of doing. And actually the only reference I found for it is referring to the PCIe Express slots. So yeah, but the board is capable of changing VCLK in BIOS. We have tested that. So yeah, it's this thing is this is a solid, this is a really, really solid board. Significant upgrade over the previous X470 Gaming 7 boards, and the Gaming K7 from X470, as well as the Gaming 5. It's a significant upgrade over both of those. Really, this is a really solid high-end AM4 X470 board. There's not really any complaints I have for it. Yeah, it's it's a good board. I'm kind of sad that it doesn't have the power and reset buttons, but for a daily user, this is quite possibly would be the best choice, assuming there isn't something weird going on with the BIOS. So yeah, physically this thing is great for like a daily system. Very, very well balanced, and with the VRM heatsink you have, you shouldn't even have to worry about like airflow at all, because this has a ton of surface area. So yeah, very, very, very solid board for like a daily build. For extreme overclocking, it would really depend on how the BIOS, the BIOS situation would also be very, very important. So yeah, that's it for the video. Thank you for watching. Like, share, subscribe, leave a comment or any questions down below. If you would like to see more videos like this, I have my own channel called Actually Hardcore Overclocking. And if you'd like to support what we do here with Gamers Nexus, where there's a Patreon and shirts, you can find links to those down in the description below, as well as in the comment section as well. That's it for the video, and see you next time.